Welcome to this explainer. All right, let's just dive right in today because we're looking at a massive paradigm shift. For the longest time, we've basically treated AI like a super smart magic 8 ball, right? You ask a question, you get a direct answer. But that era is ending. What we're exploring today is how the entire industry is fundamentally changing its approach. We're moving away from that simple one-on-one chat and evolving into a structured, highly disciplined, multi-agent team. It's a genuinely fascinating evolution, and I am so excited to break down exactly how it all works for you. So here's a quick look at our agenda for today. First, we'll cover the end of the question-answer era. Second, we'll meet the AI team. Third, we'll look at the mechanisms of agent interaction. Fourth, we'll talk about why role distribution actually works. And finally, number 5, we're going to give you your own personal AI protocol. All right, part 1, the end of the question-answer era. Now, I'm pretty sure you've experienced this exact thing. You ask an AI to write a script or, solve a complex problem. And while it gets some of it right, it makes these incredibly simple, just frustrating mistakes. Why does it do that? Well, it's all about cognitive overload. When you ask a single AI model to be the brainstormer, the architect, the programmer, and the QA tester literally all at the exact same time, it just gets overwhelmed. It loses context because it's trying to wear way too many hats. This perfectly illustrates the core issue. Traditionally, we've used this direct answer approach. That's one completely overloaded AI trying to juggle planning, coding, and testing all at once. But if you contrast that with the new industry standard, which is the multi-agent system, it's like night and day. Instead of one AI doing absolutely everything, we use specialized agentic workflows that pass tasks along. It is a complete game changer. Which brings us to section 2, meet the AI team. First up on our new AI team, we have the planner. You can think of the planner as your system architect. When a complex task comes in, the planner doesn't write a single line of code. Not one. Instead, its entire job is to analyze the prompt, break it down into manageable subtasks, and form a crystal clear sequence of logical actions. It's just laying that vital foundation. Next, we have the coder. This is our technical executor. And notice the crucial requirement here. It writes code strictly according to the plan handed down by the planner. It doesn't second-guess the architecture, and it's not distracted by testing. Its laser focus is pure execution. Then we introduce the critic. Honestly, I absolutely love this role. The critic acts as the eyes of the system. It's an independent reviewer that looks at what the coder just produced and ruthlessly evaluates it for logic flaws, security vulnerabilities, and overall efficiency. And because it didn't write the code itself, it has total objectivity. It has zero ego about the work. It just wants to find the bugs. Finally, rounding out the team is the executor. The executor grounds this whole theoretical process in harsh reality. This agent sits in a sandbox environment, takes the code, and actually runs it. If the code breaks, the executor captures those traceback errors and hands them right back to the team for analysis. It is the ultimate reality check. Moving on to section 3, mechanisms of agent interaction. So, having a team is great, but let's look at how these agents actually share data to get the job done. There are 3 main mechanisms. First is a chain. This is simple sequential data transfer, basically passing the task down the line like a factory conveyor belt. Second is iterative refinement. This is where the magic really happens. It's a cyclic loop where the critic continually kicks the code back to the coder for rework until it passes every single test. And the third is reflection. I really want to pause on this concept of reflection because it is huge. In the past, if an AI got an error, it might just blindly try again, or completely ignore the context of why it failed in the first place. But with reflection, the AI engages in advanced self-analysis. It stops, looks at the error report from the executor, and actively analyzes the root cause of its failed approach before it even attempts to generate new code. It's actually learning from its mistakes in real time. All right, section 4, why role distribution works. When we directly compare the two approaches, the difference is just striking. Under a single model, the cognitive load is overloaded, which leads to AI fatigue. But with a multi-agent team, that load is distributed, keeping each agent highly focused. When it comes to objectivity, well, a single model is notoriously blind to its own mistakes. It kind of thinks everything it writes is perfect. But the team approach uses the independent eyes of the critic. Finally, resilience. A single model is incredibly prone to getting stuck in a loop of recursive errors.
The multi-agent system actually hears the hard truth of errors from the executor and adapts. It cures the fatigue and the blindness of standard AI. And finally, Section 5, your personal AI protocol. Now, theory is great and all, but you don't actually need a complex enterprise backend to benefit from this logic today. You can simulate this exact team right now, just using a standard chat window. Here is your 4-step manual protocol. Step 1, planning, where you demand an architecture. Step 2, coding, where you force it to write based only on that plan. Step 3, self-reflection, demanding it finds vulnerabilities. And step 4, the fix. Let's walk through the exact prompts you need to copy and paste to make this happen. To trigger your planner, you're going to use this prompt for step 1. Act as a system architect. Create a detailed plan to solve this task. Break the implementation into logical steps and define the necessary functions and data structures. This simple prompt forces the AI to stop trying to code immediately and just think about the blueprint. Once it gives you that plan, you move to step 2. Trigger the coder with this prompt. Thank you for the plan. Now, as a programmer, write clean and efficient code for each of these steps. Use a modular approach, add comments to key sections. Basically, you're forcing the AI to stick strictly to the architecture it just created. No going rogue. Now for step 3. This is the secret sauce. You must invoke the critic. Reply with, analyze the code you just wrote for security, performance, and reliability. Find 3 potential errors or vulnerabilities, like null pointers or incorrect data types. Describe what these errors look like. By demanding exactly 3 errors, you force the AI to look at its own work critically and find flaws it would absolutely otherwise ignore. And finally, step 4, the executor's fix. Prompt the AI with, here are the weak spots we found. Rewrite the code taking these critical comments into account. Add exception handling to make the program resilient to these errors. What you get back after this step is a highly polished, robust final product that is leaps and bounds better than what you'd get from a single-shot prompt. You know, the source material we analyzed today perfectly summed up the value of this approach with a brilliant metaphor. Using this protocol transforms AI from a fast but inattentive intern into a disciplined professional engineering group. It's a massive leap in quality and reliability. Which leaves us with a pretty fascinating thought to end on. We've seen how you can turn your standard chat window into a planner, a coder, a critic, and an executor. But if your AI is now acting as the entire disciplined engineering group, what exactly is your new role in the process? Are you the client? Are you the manager? Maybe the visionary? It's definitely something to think about as you start putting this protocol to work. Thanks so much for joining me for this explainer, and I'll catch you in the next one.